Good afternoon, class. We are looking at section 2.3, limits of functions at finite numbers. So we looked at limits of sequences, limits of functions at infinity, and now limits of functions at finite numbers. Again, the synopsis of what we have learned: a sequence is an ordered list of numbers or function whose domain is the set of natural numbers. Limit refers to a long-term behavior. That means take a limit of a sub n and then goes to infinity. If it's some specific number L, we say it converges to L. If it's infinity, negative infinity, or doesn't exist, it diverges. This expression is going to give us a limit which is 0 simply because the denominator is getting larger and larger. And in this case, r to the power of n as n goes to infinity, the limit depends on the value of r. Between -1 and 1 becomes 0, larger than 1 becomes 1. Geometric sequence, when we add them up, is a geometric series. Here's the sum. When it's between -1 and 1, we can see that this goes to 0 and it becomes a over 1 minus r. We remember the geometric sequence, the solution in recursive format, in explicit format, and B0 or A is the first term. When we add a constant, it's like giving medication to patients. R is the percentage that remains in the body, and C is the constant that we add at a given time step, and it gives us the following result: A or B sub 0. Horizontal asymptotes, when we take a limit of a function as x approaches negative infinity or infinity and it results in a number, then y equals L represents the equation of a HA, short for horizontal asymptote. All right, let's go to 2.3, limits of functions at finite numbers, finding limits by numerical and graphical methods. Definition: the limit of f of x as x approaches a equals L. The limit of f of x as x approaches a equals L. That's how we read that. The limit of f of x as x approaches a may be positive or negative infinity, or as we approach a from the left. This a, the minus sign at top, means a from the left. This means a from the right. Whether it's infinity or negative infinity, that doesn't matter. As long as we get that, that means a VA, short for vertical asymptote. This is vertical. Now I want you to pay attention to this very important definition. One-sided limits. A function has a limit at a if. Look at this one. This refers to the limit of a function as x approaches a from the left. Look at this one. The limit of a function as x approaches a from the right, and they must be identical. If they are, then the limit of f of x as x approaches a equals L, and it does exist. That's a very important definition, everybody. So I want you to look at the graphs, compare and contrast. Take a look. When we look at all these graphs and we are interested at A, whether we come from the left or right of A, it doesn't matter. From the left of A, we go to this branch and we are shooting towards this point. From the right of A, in this branch, we are shooting towards the same point. The limit is L. The same thing for this one, the same thing for this one. In all cases, the limit exists. And the limit of f of x as x approaches A equals L in all three cases. What are the differences? In this case, the functional value at A, see, we have a solid point here, has y coordinate B. For this case, we don't have any solid point. So what is f of A? I have no idea. It's not given to us. You can say it's undefined. So this is the main thing. Part A, f of A equals L. So the functional value is equal to L also. And that refers to the fact that it's continuous, therefore. Over here, f of A is equal to B, but B is not equal to the value of the limit. And over here, what is f of A? We don't know. It's not given to us, class. Okay. So that's important to understand. We want to guess the value of this function. There are three methods. We can do it numerically, graphically, and more importantly, algebraically. So let's take a look at what happens. This is not defined when x equals 1. The reason why, because the denominator becomes 0. If we want to go with the numerical method, we choose numbers close to 1 from the left side, such as 0.5, 0.9, 0.99, 0.999, and 0.9999. Please understand 0.5, even 0.9 is way too far. And then we plug it into this fraction, evaluate it, we get there. Let's do the same thing from the right side of 1. From the right side of 1, 1.5, 1.1, and we get closer and closer to 1. And I hope you see, if you look at this value, and this value, you can see from the table the answer is 0.5. This is a numerical method. We are mostly interested in algebraic method, but you should understand all of it. We can also graph this. As you can see, this is number 1. Left of number 1. Left of number 1, that means numbers very close to 1 but smaller than 1. Right of number 1, that means close to 1 but larger than 1. From the left side, we are in this branch. We are moving towards this point. From the right side, we are moving in this branch. We are moving towards the same point. And therefore, along the y-axis, we are coming to 0.5. The limit does exist, and it's equal to 0.5. Numerically, graphically, no questions about that. Can we do this algebraically? And the answer is yes, because if you plug in this gives you 0 over 0, which is indeterminate, and it means more work, and it means we have to use our algebraic techniques. In this case, it's factoring. I went over a squared minus b squared, which is a minus b, a plus b. So this is x squared minus 1 squared, can be factored out. X minus 1 will be dropped from the top and the bottom. And the numerator changes to 1. And now there is nothing else we have to do except plug in number 1. And as you can see, the final answer is 1/2. And that's exactly what we got here. Meaning, numerical method, graphical method, algebraic method, all of them prove the same thing, and we are done. Again, I'm reminding you of the one-sided limit. Function h, the name is Heaviside. H of t equals 0 if t is less than 0, and it's 1 if t is larger than or equal to 0. The limit of this function as t approaches 0 from the right, you use this part, and the answer is 1. So this symbol x approaches a from the right, this means that we consider only x larger than a. So again, we read this a from the right. From the left side, we consider the top branch and it becomes 0. And this means a from the left. Please understand, doesn't mean negative or positive, it's just left and right. That's all it means. For example, if we are looking at number 5, both sides of number 5 are positive. The left side is like 4 point, example would be like 4.9, and the right side would be like 5.1. Doesn't mean negative or positive, okay? The only number that the left and right side have different signs is 0. To the left is negative, to the right is positive. And that is something you want to be careful. If you are approaching 0, the left of it is a negative number and the right of it is a positive number. That's the only number that things can be interesting. All right, and therefore the limit of h of t as t approaches 0 does not exist. And the reason is because they must be identical. So we have the limit. To make some sense out of this, and of course, by the way, h of 0 is 1, the reason being because of the equality. H of 0 is 1, the limit doesn't exist. All right, we want to find the limit of this function, and we have the graph as x approaches 2 from the left, 2 from the right, and g of x as x approaches 2. I want to give everybody a minute to think about it. Look at the graph. You want to follow the graph that is given, because if you want to draw it, you may miss something. So just look at the graph and understand what this means. 2 from the left, like 1.9999. That's really the concept, if you will. So 2 from the left, we are coming this way. That means we are in this branch. That means we end up here. And that means the answer is 3. So one more time. 2 from the left. If I were to put arrows for left, this is the left of 2. That means you are moving towards the hole here in this branch. For 2 from the right, this is 2 from the right. We are in this side of number 2. We are in this branch and we are moving towards this point, and it's 1. So take a look at the right side. So if I'm coming to number 2 from the right side, I'm moving in this direction. Again, I never get there. It's not important. It's just that we are moving towards that. And that's the answer. Because the two are not identical, the limit of g of x as x approaches 2 does not exist. Okay. In fact, what is g of 2, the functional value? If you have a solid point here anywhere, then the y coordinate of that would be g of 2. I don't have it. So the next part is asking what's happening to number 5. Let's give everybody a chance to work on number 5. See if you can figure this out. We'll discuss that in a moment. See if you can see if you can figure this out. If we come from the left side of phi and the right side of the phi, left side we go this way, right side we go this way, and in both cases we are moving towards this point. And whatever the value is the limit. So this is 2, so is this one. Therefore, the limit does exist, and it is equal to 2. That is extremely important to see. We are looking at the limit. The function is discontinuous at that point because we have a hole. But what is the meaning of this? Okay, that means the function does have a functional value at 5. In other words, there is such thing as g of 5. If you look at this point, seem to be almost 1.4, something close to that. Therefore, g of 5 is almost 1.4, but it is not equal to 2. Because they are not equal, it means it's discontinuous, but the limit does exist. In fact, the terminology is a removable discontinuity because we can fix the discontinuity. Let's look at this case. You want to find the limit of f of x as x approaches 2 from the left, 2 from the right, and 2. So 2 from the left going this way. That means we're moving in this direction. And whatever the y coordinate for this point is, I hope everybody is clear. You read it here. It's 1, 2, 3. Okay. From the right, you're moving this way. You're coming to this point, which has a different y coordinate 1. Because these two are not identical, the limit does not exist. So we are going from the left here, from the left here, from the right this way. This way we have different answers there. All right. Now, what is f of 2? F of 2, because we have a solid point here, the answer is this y coordinate, which is 3. What is the limit of f of x as x approaches 4? Look at 4. Whether I go from the left side of 4, I'm in this branch, I'm moving here. Right side of 4, I'm in this branch. In both cases, I'm going towards this point, which has the y coordinate 4. But what is f of 4? I don't see a solid point. I have no idea. Undefined. So I hope everybody's clear. So let's quickly recap. Number 2, what is f of 2? The y coordinate for this solid point. Number 4, what is the limit? Both sides are going here. They never get there, but they're going there. And this hole has a y coordinate of 4. But what is f of 4? I'm looking for a solid point. I don't find anything. It's undefined. It's not given. All right, infinite limits. This definition is illustrated graphically in following figure. Similar definitions can be given for the one-sided infinite limit. So take a look at this. If you take a limit as x approaches a, notice a from the left and a from the right. In both cases, it blows up to infinity, whereas in this case, in both cases, it goes down to negative infinity. So whether or not it happens from both sides or one side, this is from the left, this is from the right of A. This is from the left, this is from the right of A. It doesn't matter which one. Any of these cases, all of these cases, this x equals A, this vertical line has a name. It's VA, vertical asymptote. In all those cases, the line x equals A is a vertical asymptote. A simple example. y equals ln x, we know that the vertical asymptote is the x-axis because the limit of ln x as x approaches 0 from the right is negative infinity. And I hope you remember the graph. The graph will remind you of this effect, and therefore VA, short for vertical asymptote, has the equation x equals 0. X equals 0. Let's look at a simple example of this. We are given the graph. We want to find the limit of the function r of x as x approaches various numbers. First, number 2, then number 5, and then number 3 from the left, negative 3 from the left, negative 3 from the right. So as we look at the first one, number 2, I hope you see that from the left of 2 and from the right of 2, both sides go down to negative infinity. So number 2, left and right, they are going down to negative infinity. Number 5, left and right, both of them are going to positive infinity. In fact, I mean, you can draw a vertical line. And by the way, when you draw a vertical line, in this case, vertical asymptote should be a dashed line. So when we look at the limit as we approach negative 3 from the left, I hope you see that from the left of it, it's going down to negative infinity. From the right of it, it's going up to positive infinity. If somebody says, what is the limit of r of x as x approaches negative 3? That it, because they don't match, it doesn't exist like the previous ones. But nevertheless, all of them result in the following vertical asymptotes: x equals 2, or from here x equals 5, these 2, x equals negative 3. So that will justify the existence of a vertical asymptote. So understanding graphs. Okay. We want to find the following limits. I hope you see that if I plug in, I get square root of 4 minus 2, which is 0 over 0. So if you plug in, you get 0 over 0, which is indeterminate. And I hope you remember the technique was to multiply by the conjugate whenever you have a square root. So we're going to multiply by the conjugate of the numerator, which means the same thing plus 2. So we're going to multiply and therefore divide by it. Because this expression is equal to 1, it's justified. Now what happens to the numerator? We end up with square root of x plus 4 squared minus 2 squared. But what happens to the denominator? Nothing. You don't touch it. You keep it as a product. You don't distribute. Do not distribute. Keep the denominator intact. 4 and negative 4 cancel each other. The numerator is x. And now, if you cross out the x. This is the answer that we are ready to plug in 0. When we plug in 0, we get square root of 4, which is 2, and 2 becomes 4. So 1 over 4 is the final answer. There's two questions I want to look at them at the same time because I want to compare and contrast. I hope you realize that when they say -3 from the right or -3 from the left, if you plug in both cases, the top is -1, the bottom is 0. But there is a difference between the two, and that's what I want to discuss. See, when you plug in a number from the left and right, -3 from the right and -3 from the left are almost the same. They're not identical. And it really makes no difference for the top. You have to add -3 and you get -1, the same thing here. But when you add -3 here, you get 0, -3 here, and a 0 makes a difference. Now, both of them are -1 at top, but the 0 at the bottom here, it could be 0 from the right or 0 from the left. And that's why you want to be careful. To understand that, you literally have to pick up a number. When we say -3 from the right, so we have number -3 here. The right side of -3, it's like, let's say, -2. Close to that would be -2.9. So if you look at this, -29 plus 3 gives you 0.1, which is a positive value. So you have -1 over 0 from the right. Why is this important? Because we know this blows up to infinity, but the sign is negative because the top, and this one is -1 from the over 0 from the left. But let me just show you this one. From the left side, like -3.1 and -3.1 plus 3 is -0.1, and that's why this gives the negative sign for here. So -1 is the numerator. This one is 0 from the right. This one is 0 from the left. Both of them go to infinity. This goes to -infinity, and this goes to +infinity because negative over negative is positive. And that's why you want to be very careful when the denominator is 0, because both sides make a huge difference. I'm going to make some more sense out of this by looking at more examples involving 0 in the denominator. So x is approaching 5 from the left, and whether it's from the left or right, the top is e to the power of 5, very close to e to the power of 5, makes no difference, which is a very large number, positive number. What matters is that the denominator goes to 0, so you really have to figure out how to come up with the answer, because it's 5 from the left, let's say like 4.9. So 4.9 minus 5 gives us -0.1, which means the denominator is 0 from the left. Now, we keep the exponent as it is. We know that a negative number to the power of odd remains negative. Therefore, this is still 0 from the left. When you raise it to the power of 3, positive value over negative value makes it negative. And I want to make sure you understand this. So I'm going to give you the same question, but I'm changing the exponent to 4. So what happens is that you write the same thing here. But because the exponent is even, class, this was odd, we got zero, we got a negative value. This is even. A negative number, for example, -5. When you square it, you get positive 25. So this now will change to the following. Therefore, it's positive infinity. And that's something you want to be very careful of. How do we arrive at positive or negative infinity? For number 36, if you plug in, you get 0/0. And even if before you plug in, anytime you have a rational expression, if you can simplify by factoring, you must. But just in case, if you plug in, you get 0/0. And for the top, obviously, x is in common. For the bottom is x² minus 4x plus 4. I'm going to write a couple of things for you. A² plus 2ab plus b² is a plus b². If you have a negative sign here, you have a negative sign here. And that's why we have x minus 2 quantity squared. Again, just to remind you of this. This x minus 2 goes away and this exponent goes away. And as you can see, if I plug in 2 from the left or right, the top is close to 2. That means whether you write 1.9 or 2.1 makes no difference. We want to discuss the bottom. So the top is 2, or very close to that. But what happens for this one? 2 from the left means like 1.9 minus 2, negative 0.1. The only reason I'm picking number just to, so I can figure out the sign 0 from the left or 0 from the right. In this case, is 0 from the left. We know the answer is infinity, but it will blow up to negative infinity because the numerator is positive, the denominator is negative. So the final answer is negative infinity.